And there we go.
Got it.
All right. You tend to do the intros more often. Would you like to lead us off?
The intros, I write them all. I don't make them up on the spot. I'm not that good yet.
Hi, this is Brian from Let's Code Physics. I sat down with Brad Moser of Physics Alive and Hamilton College and Ann Leek of High Point University to talk about our reflections on the 2022 winter meeting of the American Association of Physics Teachers. In the 2 hours we spent recording, topics included quantum mechanics, board games, quantum mechanical board games, representation in physics, and what we hope to see in future AAPT meetings. I've split up this conversation into 6 bite-sized episodes that we hope you'll enjoy.
Today was it's on the calendar as the second day of the winter meeting, but this was definitely the first day of talks during the AAPT winter meeting of 2022, which everybody is saying will hopefully be the last virtual one. We'll see if that's true at the end of all this.
To elaborate on that point, a couple of times the folks from AAPT I've met with say they are committed to an in-person meeting in summer 22 in Grand Rapids, Michigan. I mean, certainly, hopefully by that point, all ages will be eligible for the vaccine. And so then it's, I mean, that's kind of the best we can do, at that point, apart from another enormous spike going on. Somebody did mention in the chat during the plenary today that they would try to have some remote component to it, because I do know they've seen, except for this meeting, we might talk about that in a second, but except for this meeting, they have seen more attendance at the virtual meetings because travel is a significant, barrier for a lot of folks, either financially or getting away from work responsibilities or arranging childcare, et cetera. And so being able to pop in remotely certainly is beneficial to people. But I think, we were talking about this before we started recording. We're all kind of feeling the slog, as it were, of so many virtual meetings at this point.
Yeah. Well, it's interesting you mentioned that there's a sense that maybe the attendance has been a little bit up because of that, of being more able to attend based on the cost and whatnot, especially given the numbers. I attended the meeting of the members last night, and one of the ideas brought up in the meeting was that attendance at AAPT meetings has been falling, not just in pandemic times, but over the last decade. And the numbers of membership has fallen by about 1,500, 2,000, but especially amongst high school teachers,
especially amongst high school. Yes.
Which you think are the ones who are probably not getting much funding from their school to go travel to a conference. And in the winter meeting, they're in session.
Right.
I guess the summer meeting, they're probably off. And I guess that's when a lot of the high school teachers tend to attend.
Yeah. I'm
not sure.
I've been getting confused about that the last couple of years, because the winter meeting is always smaller than summer, because summer is more guaranteed to be able to get away from work responsibilities. Winter it seems to be hit or miss for people, but it seems like both the high school and the university presence is stronger at the summer meeting. I know at least on the PER side, PER is way more represented at summer than it is at winter.
Okay.
And so maybe it's the folks who are sort of in the middle of, well, I teach, this is also sort of my scholarship, maybe that's where the winter meeting comes in, and the folks who need, who need another presentation for the year, or who need another workshop to figure out what they're doing for their class or something. I'm not sure. That would be an interesting, it would be interesting to break that down by demographics, I feel like.
Well, for our listeners who have joined us today, and thank you for doing so, or our YouTube listeners, YouTube watchers, or podcast listeners, you probably don't watch the podcast.
Audience.
The audience, you're here for, well, thank you for joining us. And we would like to talk about, our impressions and things that we remembered from this first day of the meeting. We'll also do this after the second day as well. Who knows how this will be released on my podcast? It might just be, I'll smush them all together, but maybe they don't want to hear us blabber about our thoughts about how to solve the crises, but maybe it's like, what did we learn today?
What did we learn from all the wonderful people we heard from? So
yes, there were a lot of fantastic talks.
Even though this is now a two dudes talking episode, we really want to use our voices to promote the other voices that we heard from. And so I know I've got the links to the stuff I went to today open. And so I think we can try to compile those, to try to direct people to, whatever sort of resources we can. But I think we were going to start, just kind of go chronologically, start with the plenary. I know we were both there. Brad, what was your main takeaway from the plenary session?
Well, and I don't know if everybody listening was in attendance today. So we heard it was a talk called Physics for All, Wonder, Magnificence, and Joy by Fred Myers, who taught for 42 years in high school. That is amazing to think about. And sort of just the way he described it, like you can hear the generations and as they changed, but probably the story that I think got the gasps from everybody, not that you could hear any gasp online because
you could see it in the chat,
but you could see it in the chat, was he told this story that he brought, and he showed this top that his father had given him, a spinning top, and he wanted to show it to his teacher. I don't remember all the details of the story already, but he wanted to be able to talk about the physics of that to the class. And somehow the teacher basically took his hand and was squeezing on his hand until he yelped in pain, and then said, "Don't ever, ask that type of question again. Go sit down." And I just think, oh my gosh, okay, that can't happen in the world nowadays in our classrooms. I hope. I mean, hopefully not in the US, but maybe it doesn't happen physically, but I feel like it could still happen psychologically so easily if we're not careful. And I think we're seeing a lot of the shifts in that especially over the last few years with thinking about diversity, equity, and inclusion, thinking about this for the underrepresented groups, but for everybody as a whole. And I think on my podcast, I've shared an experience I had in graduate school where I was, in a sense, I wasn't called stupid for not knowing something, but I was definitely made to feel it as such with a very sharp response. And it's not a good feeling. And it's something that stuck with me. And Fred said, it's like, I wasn't scarred by the situation. And then he said, it's like, but since I'm telling the story 50 years later, it's like, maybe I was.
Yeah.
And he persevered through it, but that's not true for many people.
Yes. I mean, you think about, we use that term resilience, in situations like that. And really, people should not have to be resilient to learn about the things they are interested in. And it's like, he was resilient to get through that. Partly because he had the cultural capital to get through something like that and to come back from it and to say, well, no, physics really is for me. When a student is already thinking physics really isn't for me, I'm not supposed to be here, I kind of snuck in here, I don't look like the teacher, I don't look like anybody in my textbook. When they have an experience like that, physical altercation or no, it just reinforces that, and they don't have that, that cultural capital built up to say, no, I'm going to persevere through this because I'm really interested. They're going to say, well, I'm going to go where I'm interested and where I'm welcome.
Yeah. But on more positive notes of things, one of the things that struck me in, as he was sort of introducing himself, was he mentioned that he felt lucky and blessed to have taught for his whole career. And people can say stuff, but the way he said it, sort of the look in his eye as he was saying it, is like you could really feel that it's like he truly felt lucky that he got to spend his lifetime working with students and helping them learn. And it's the sort of thing, and just a couple of episodes that I did where I interviewed some of the education award winners last year. I got that feeling from them as well, that there was this authentic love of teaching, and it's always a joy for me to see other teachers experiencing that.
Yeah. one of the things he talked about at length was the physics first approach that he has been a big advocate for. So the way I went through in high school, and the way I think it works for most people, is they start biology, then go chemistry, then go physics, which I know we're trying to get away from pyramid diagrams, et cetera. But, when you think about the pyramid of science, where physics is the foundation, chemistry is the central science, and then biology is what you get when all this stuff happens together in a way that replicates itself. Conceptually, it kind of makes sense to start with physical principles that are sort of the foundation of the universe, the things that happen everywhere, not just with living systems. And then you get to chemistry to say, okay, when these particular sets of forces happen with these particular subatomic particles clustered together into atoms, this is what you get. This is the type of reactions you get. And then when those chemicals get together and form cells, and the cells form tissues, and the tissues form organs, we get this thing called biology. And so you could, it really, in my mind, it promotes sort of this holistic view of the universe, that everything is connected, everything is based on each other. And yet we are stuck in this pattern of going the other way. And somebody brought up a good question in the chat, which was, well, how do you support going the upward direction mathematically? Because really, in my mind, the primary reason we do biochem then physics is that we're scaling up the mathematical complexity. I mean, I remember taking ninth grade biology. I don't really remember any math in it. Looking back, I can see that those genetic tables with the dominant recessive on the columns and the rows.
Right. That's all I saw mathematically.
That's
in
kind
12th
of
grade.
That's a kind of a mathematical thing. Like it's the logical reasoning side of math, not necessarily the number crunching, function graphing stuff. And so, I understand the way we do that, but at the same time, I don't know. I feel like the average ninth grader is probably capable of more mathematically than we typically give them credit for. I don't know if you have any thoughts or experience with that.
Well, and I remember in 8th grade, I had a physical science class, and I don't really remember the mathematical rigor of that class. It must not have been too much, but I do remember, learning the periodic table of elements. I remember boron was the one that I had to make with styrofoam. And I had a positive experience from that class. So I think it seems like this idea of physics first shouldn't be that hard to come across, because if you start that in 9th grade, once you get to 12th grade, it's like, now that becomes the free for all year, that now that you've gone through your 3 sciences, now you can sort of choose what you want. So there's still a place for your AP physics,
or dare we say
honors,
or dare we say there's a place for you to do something interdisciplinary
or something else, right? Some sort of engineering or biochemistry, physics, make some sort of combo of all that.
I think it also sort of speaks to, the underlying question of what are we doing with the math in our physics classes? Because yes, we use math to do physics all the time, but a student can understand physics conceptually without wrangling 500 equations over the course of the semester. And so I kind of wonder if, you mentioned building boron out of styrofoam. I wonder if taking a more holistic model building approach might help reinforce that physics first construct, where you're, what does a truly conceptual physics course look like? I don't even know that I can separate the math well enough in my mind to even, begin to design such a thing.
Oh, that's interesting. I mean, I feel like the conceptual has the math built into it. I mean, the conceptual is we're beginning to think in terms of equations, but they don't have to be hard ones. We can, for the most part, it can be a lot of linear equations. And I think any ninth grader should be able to think in that direction. So, and I think I believe I remember Fred mentioning sort of it's like you want to make sure the math is there, but you don't want to have too much math. You should be able to find that moderated point.
Well, and who's to say that, having algebra introduced more in a physics context, that might even help them learn the algebra better, because they're seeing what it is, or one way that it is used. certainly math teachers have a challenge where it's like, well, show me an application of this. And it's like, well, what isn't an application of this? But, if they had it contextualized long-term in something like, I'll skip ahead to one of the talks I was in later today. Let's say it's in the context of increasing global temperatures. That immediately has the student's attention. We're going to do the same type of math we would be doing anyway, but now it's in a problem that we can actually talk about and have a discussion about. That's not, okay, X was equal to 7.2. Let's move on, So I'll ask a provocative question from the plenary. The speaker several times kind of made these offhanded comments, and they would say, I'm sorry, I know that sounds elitist. Usually when he would say, yay, raw physics. We all know physics is the best. Physics promotes critical thinking. Physics is all these great things. And I did not get the sense that he was actually saying physics is a superior class and physicists are superior to other people, et cetera. But I do think he was trying to capture the unique excitement we seem to have for our subject, right? So I wonder, do you think it's actually elitist for us to think that physics is quote unquote the best or quote unquote the most enjoyable, or at the very least unique among the other academic subjects in the way that we kind of approach it and are excited about it?
Oh man. You want to be up till midnight tonight? By the way, we're recording at 10:30 right at night right now after it. So
yes, this is the raw and uncut Physics Alive.
I would like to think that we can all make space for everybody to be excited about what they're excited about and have that be meaningful to them. So that if we, as folks who have gone into physics, think that this is the cat's meow for us, then that's fantastic. But realizing that for my wife, the cat's meow is biology. And maybe that wasn't for me, but I'm opening to experiencing more of that and appreciating it more. But it's not going to be my main thing, although it has sort of becoming a main thing with my interest in introphysics for the life sciences. But so that would be, I guess that's sort of my rough answer, that I would want to say that. I mean, I don't think I can stand behind physics as it's like that. It's the best. It's definitely the best.
Yeah.
I can stand behind the idea of it being a foundational piece to the other sciences. But in a way, it's like you can understand a lot of biology without understanding anything in physics. But it's certainly helpful. But so I believe there's these foundational principles that you talk about, that pyramid. And I think there is some truth to that, but I think there's also a lot that can't be described by physics necessarily in biology, unless we come up with an equation for evolution.
I very much agree with you. Because I've had these conversations with folks, not just in other sciences, but from humanities, from history, et cetera. And they come at it from the attitude of, well, no, we have to be interdisciplinary and we have to appreciate everything that humans have ever studied and, kind of try to understand everything. And I say, but I think that my subject is the best. Don't you think your subject is the best? Like when I say physics is the best, I mean, subjectively, physics is my favorite. And maybe I need to replace best with favorite, because that's a subjective thing. People can't tell me what my favorite is. But I my mind just cannot wrap my mind around the notion of going and studying something for years and years and getting a PhD and dedicating yourself to the stuff and not thinking that your subject is awesome and not thinking that your subject has something unique to offer to the world and that it's number one, at least on your list. And you're going to try to make it high up on your students list, if not number one.
Yeah.
And so maybe what I need to learn to do is communicate that subjective nature of it more clearly, because I certainly don't expect a humanities PhD to think that physics is the best. Otherwise, they would have a physics PhD. But I hope I can get them excited about it, if we have a conversation about it. That was kind of how I interpreted the speaker's comments, but I totally understand if people have a different experience with that.
Well, and there were a number of times, quite a number of times, I think, that he said, well, this is what we said back then. You probably couldn't say this anymore. And this is where we begin to see, that generational gap of, he's retired now, he's 40 years advanced of where we are. And there were different mindsets at that time. And we're shifting those mindsets now. But, a lot of those stories are going to come from a previous time.
Yeah. Okay.
I was just gonna launch into it. No, I shouldn't go. So one of the other ones, I will. One of the other ones mentioned at the meeting, the members meeting last night, was the AAPT's support for changing the name of the Webb telescope, and it brought to light some information that I hadn't heard before about this. Sort of when this individual was the administrator of an administrator of NASA, or I don't quite remember this. I didn't read through the documents they provided yet.
Probably Google. Let's just Google who was James Webb, because as I understand, he made significant contributions to advancements in NASA. Administrator of NASA from 1961 to 1968, played an integral role in the Apollo program. And so it's one of those things where it's like, that was a good contribution. That was a wonderful contribution. There are other activities that were very unwonderful.
Mm-hmm.
And so it's like, it's the constant tension between, do you honor the good things that people do, or do you dissociate from them, for the legitimately unpleasant things that they have done.
And I could, and this is where, it can be easy to make the comment of, well, that's a generational difference. It's like back then there were more people that thought A, B, and C. But it's like, but back then there were also a lot of people that didn't think that. And maybe we have to focus more on celebrating those folks who made great contributions, and they didn't fall into some of those traps of negative thought or not supporting the many groups that are out there in the world.
Yeah.